hand light switch off, kitchen morning quiet. You just flip the light switch this morning without thinking about it, cost you maybe half a cent. But by the end of this month, that one light switch and 1,000 others like it in your home will have cost you somewhere between $30 and $40. That's just one room, one habit, one assumption that electricity is cheap because you've paid for it the same way for 50 years. What if I told you that assumption is about to change everything? Utility bill, money expenses, aging hands. Most Americans over 60 on a fixed income didn't expect this. Your utility company didn't write you a letter. There was no announcement. The rates just climbed. 3% one year, 5% the next, then 7% again. And suddenly, what used to be a predictable line item in your monthly budget is eating lunch money you planned on keeping. But here's what the utility company doesn't want you to know. You don't actually need them nearly as much as they've convinced you to believe. Backyard suburban house fence, grass sky. The title of this video probably caught your eye. Copper pipes, salt, buried in a backyard. Maybe you thought it was science fiction. Maybe you thought it was too good to be true. And I'm not going to lie to you, some of what you've heard about free energy from buried metals is exactly that, wishful thinking mixed with misunderstanding. But here's the counterintuitive part that nobody talks about. The real reason those setups sometimes seem to work has almost nothing to do with what people want is happening. And once you understand the actual mechanism, you unlock something far more practical, far more reliable, and absolutely within reach for someone on your budget. Earth soil water diagram, educational illustration. The story everyone tells you goes like this. Copper and zinc buried in the earth create a natural electrical potential. Salt water in the soil acts as an electrolyte. You get a battery. Crude, yes. Weak, maybe. But a battery nonetheless. Some people claim they've powered small LED lights this way. Others say they've run fence chargers. A few bold claims suggest phone charging is possible. And technically, they're not entirely wrong. There is a small electrical potential created. It's real, it's measurable. But here's what changes everything. That potential is so small and so inconsistent that trying to build a practical system around it is like planning your retirement around winning the lottery. So why am I making a video about it? Copper wire spool hands, DIY project. Because the real discovery isn't the buried pipes themselves. It's what happens when you stop thinking about them as an energy source and start thinking about them as part of something bigger. Something you can actually control, something that doesn't rely on magic or pseudoscience. Something that works whether the sun is shining or not, whether it's windy or still, whether you're in the city or deep in the country. The people who get results from these setups, the ones who actually power lights consistently, they're not relying on the earth battery itself. They're using it as a component of a different system entirely. And that system is so simple, so affordable, and so overlooked by the mainstream energy industry that I'm genuinely shocked more people aren't talking about it. Workbench tools, materials, DIY copper pipe. Here's what most people miss. A standard earth battery, copper and zinc in salt water, generates voltage. Real voltage. Maybe half a volt, maybe a full volt. Not much. Not enough to power anything by itself. But voltage isn't the only thing that matters. What matters is what you do with that voltage once you have it. You see, for the last 60 years, we've been taught that electricity is a finished product. You flip the switch, power flows, the light comes on. You never had to think about where it came from or how it was made. The utility company did that for you. That assumption that you're helpless without them is the entire foundation of their business model. But the moment you understand that electricity is just potential energy in motion, everything changes. Because once you have a source of that potential, even a tiny one, you can amplify it, you can store it, you can direct it. Electricity diagram, light flow, animated circuit. And that's where most tutorials stop. They show you how to bury copper in salt, they maybe get you a small light to flicker, and then they pat themselves on the back. But that's not a system, that's a parlor trick. What if I told you that you could take that same setup, literally the same components, the same backyard project, and combine it with something you probably already have sitting in a closet or garage? Something that costs less than $20. And suddenly, instead of watching a single LED flicker unreliably, you're powering a real light, a bright light, a light that runs all consistently every night, rain or shine, with almost zero ongoing cost. Person walking backyard shed, evening light. That's the gap between what people talk about and what actually works. I've been researching energy independence for retired Americans for years now. I've seen hundreds of videos about solar panels. Amazing technology, yes, but easily a $10,000 investment before it pays for itself. I've watched tutorials on battery banks, wind turbines, and grid tie systems. All valid, all useful, but all expensive. All requiring permits, inspections, professional installation, all things that feel out of reach for someone on a fixed income who just wants to stop hemorrhaging money on electricity bills. But this is different. Hands opening box materials, cardboard DIY. The approach I'm about to walk you through costs between $40 and $90 in total materials. It can be assembled in a weekend, it requires no electrical license, it requires no permits, it requires no inspection, and once it's running, your maintenance time is roughly zero. You check it once every few months, that's it. But before I dive into the specifics, I need to address something that a lot of people get wrong about setups like this. When you bury copper and salt in the ground, you're not creating unlimited free electricity. That's not how physics works. That's not how thermodynamics works. What you're actually creating is a very slow, very weak charging source. Think of it like a trickle charger for a car battery, except the trickle is almost microscopic. Over the course of a single day, a copper zinc salt battery in the ground might accumulate enough charge to power an LED for a few hours. That's it. That's the honest truth. If someone is telling you they're powering a TV or running a whole room with one of these, they're either lying or they've built something much more complex than they're admitting. Defense light night, LED glowing, backyard. So why would you build this? Why would you spend $80 and a weekend on something that only generates enough power to run a small light? Because that's not where the real value is. The real value is in what happens when you understand the principle, when you replicate it, and when you scale it up intentionally. When you stop thinking of free electricity from the earth as a standalone system and start thinking of it as one tool in a larger toolkit, when you combine it with other low-cost components that amplify, store, and distribute the power you're generating, that's when you start seeing actual results. That's when a retiree on a fixed income can legitimately reduce their utility bill by $50, $100, sometimes more per month. That's when the whole thing stops being a curiosity and becomes a practical strategy. Utility meter spinning, DIY setup simple. The first thing you need to understand is the difference between generation and accumulation. An earth battery generates electricity continuously, but the amount is so small that it's barely measurable. What you need is accumulation. You need a place to store the tiny trickle of power over time so that when night falls, you have enough charge to power something meaningful. That's where people usually get stuck. They see the copper and salt, they get excited about the concept, and then they try to run a light directly off the battery. It flickers, it's unreliable, it disappoints them, and they assume the whole thing is a scam. But that's because they're skipping a crucial step, the accumulator. Rechargeable battery hands, close up. Here's the system that actually works, and here's why it works. Your buried copper zinc salt battery generates a tiny voltage. Not much, maybe 0.5 to 1 volt. Not enough to run anything on its own. But if you connect that voltage to a charging circuit, a simple, inexpensive component you can buy online for $5 to $10. That circuit can collect and concentrate that trickle of power into a rechargeable battery. The rechargeable battery sits in your shed or garage. It's not in the ground. It's protected from the elements. It's connected to your buried setup via simple wires, and slowly, day after day, that earth battery trickles charge into the rechargeable battery. After 2 weeks, you have enough stored power to run a decent LED light all night, every night, for an entire week. Then the cycle continues. The earth battery keeps charging, the rechargeable battery keeps accumulating power, and you've got a light that runs continuously at virtually zero cost. Circuit diagram electricity flow, colored technical 7. But here's the counterintuitive part that changes everything. Once you add that rechargeable battery and understand how to charge it, you don't have to limit yourself to just the earth battery. You can charge it faster, using other methods too. That's the breakthrough most people miss. A solar panel, even a cheap 10-watt one you pick up for $30, can charge that same battery much faster than the earth battery ever could. A small hand crank generator can give it a boost in 5 minutes. A wind-powered charger can trickle charge it on breezy days. An old phone charger you were about to throw away can charge it from your home solar setup. Suddenly, you're not relying on any single source of electricity. You're not dependent on weather, on seasons, on luck. You're layering multiple small sources of generation so that even if one fails, the others are still working. That's resilience. That's what the utility company can't sell you. Solar panel small, hand generator crank. This is where the philosophy shifts from free energy to independent power. And that shift is everything. Most people approach this topic by asking, how can I get free electricity? That's the wrong question. The right question is, how can I stop paying the utility company so much money? Those sound similar, but they're fundamentally different. Free electricity is a myth. Every form of energy generation has a cost. It's either your money or your time or your labor. Reducing what you pay the utility company is absolutely achievable, especially if you're willing to combine multiple small systems instead of betting on one big one. Woman utility bill calculating, kitchen table. For most retirees, the goal isn't to go completely off-grid. That's a nice idea, but it's often impractical. The goal is to reduce the utility bill from $180 a month to $100, or from $140 to $70. That's still a significant amount of money on a fixed income. That's groceries, that's medication, that's peace of mind. And that's absolutely within reach, using the approach I'm describing. Here's where most DIY energy videos get it wrong. They focus on the flashy part. They show you the buried copper and salt like it's some kind of magical discovery. They get you excited. They make it seem like the hard part is understanding the concept. But the hard part isn't the concept. The hard part is scaling. The hard part is combining the right components so that you actually generate enough power to make a difference in your utility bill. The hard part is doing that affordably, safely, and reliably. Workbench project materials, organized components. That's why I've put together a detailed guide that walks you through the entire system. Not just the buried battery part, that's the sexiest part, but it's only about 20% of what actually makes this work. The guide covers the accumulation system, the charging circuit selection, the battery type you should use, the safest way to wire everything, how to weatherproof your above-ground components, and most importantly, how to combine this with other low-cost power sources so that you're actually generating enough electricity to move the needle on your utility bill. You can find that guide in the description and pinned comment. It goes much deeper than what I can cover in a video like this, and it includes real examples from people who've actually implemented these systems. Person walking outside patio door, backyard entrance. Now let me walk you through what the actual project looks like, step by step. Step 1, you're going to prepare your burial site. You need a spot in your yard that stays relatively moist. Ideally, that's somewhere near a downspout or in a shaded area where water drains naturally. The saltwater electrolyte in your buried battery needs moisture to work. If your soil is completely dry, the system doesn't function. Shovel soil digging garden. Backyard earth. You'll dig a hole about 2 feet deep and a foot in diameter. This isn't complicated. It shouldn't take more than 20 minutes. You're just creating a space where you can bury your battery components safely, away from foot traffic, and where they won't accidentally get disturbed. Step 2, prepare your electrode materials. You'll need 2 pieces of metal, ideally copper and zinc, though copper and steel will also work in a pinch. These should be about the size of a pencil in diameter and maybe 4 to 6 inches long. You're not trying to maximize surface area here, you're just creating a reliable, consistent electrical potential. Take those 2 pieces of metal and solder or firmly connect a length of copper wire to each one. These wires are what will come up out of the ground and connect to your charging circuit. They need to be long enough to reach from your hole to wherever you're planning to put your charging system, ideally your garage or a weatherproofed shed. Soldering iron, metal wire, hands detail. Use a soldering iron, they're cheap, under $20, and make solid connections. Don't use tape, don't use twist connectors. Those will corrode underground and fail within a few months. A solder joint will last years. Step 3, prepare your electrolyte. You'll mix water with salt, not a tiny bit of salt. This needs to be a saturated solution. Basically, you're mixing salt into the water until no more salt will dissolve. You want a really strong electrolyte. This is the medium through which your electrical potential will be created. Some people use a large jar, some people use a porous clay pot. The idea is that the electrolyte needs to stay in contact with both electrode metals, but it shouldn't spill everywhere. If you're using a jar, just make sure it's big enough to hold both your copper and zinc pieces submerged. Jar saltwater dissolving, hand sprinkling kitchen. Pour your electrode metals into the jar so they're both submerged but not touching each other. If they touch, you've created a direct short and your battery won't work. They need to be close, maybe an inch or 2 apart, but not in contact. That's your earth battery. That's the complete unit. Now, you're going to bury it in your prepared hole. Step 4, burial. Take your jar with the submerged electrodes and the wires running out of it, and place it carefully in your hole. The wires should come up and out toward wherever you're planning to put your above-ground components. Once it's positioned, you can backfill the hole with soil. Jar buried soil hole. Hands digging. Here's something crucial that people usually skip. Mark the spot. You don't want someone digging there later and damaging your setup. I like to use a small plastic flag or a stake with some bright tape, just a visual reminder that there's something there. Step 5, your above-ground system. Now that your earth battery is buried and generating a tiny electrical potential, you need to do something with it. This is where a charging circuit board comes in. It's a small printed circuit board, usually costs $5 to $15 on Amazon, and its job is to take that tiny inconsistent voltage from your buried battery and convert it into something useful that can charge a rechargeable battery. Specifically, you want what's called a boost converter or an MPPT charge controller if you want to get technical. The idea is that it takes the variable low voltage output from your earth battery and boosts it into something more consistent that a standard rechargeable battery can accept. Circuit board, microchip wires, electronic component. You're going to connect your wires from the buried battery to this charging circuit. The circuit board then connects to your rechargeable battery. From there, you can run wires to any low voltage lighting or device you want to power. The most practical setup for someone on a fixed income is to charge a simple lithium-ion battery, maybe a 10,000 milliamp hour capacity, which you can pick up for $20 to $30, and then use that battery to power LED lights or small devices as needed. Rechargeable battery pack, lithium-ion, held. The beauty of this system is its redundancy. If your earth battery stops working for some reason, and eventually it will because metals corrode, salt solutions become saturated, you haven't lost anything. You just need to refresh the system. Replace the salt water, maybe eventually replace the electrode metals after a few years, but while it's working, it's essentially free electricity trickling into your battery 24/7. Let me give you a realistic picture of what to expect in terms of actual power generation. A single copper zinc salt battery generates roughly 0.7 volts, and under ideal conditions with a good charging circuit, maybe 50 milliamps of current. That doesn't sound like much because it isn't, but over the course of a full day, that's roughly 1,000 milliamp hours of charge. In battery terms, that's about 1/10 of a kilowatt hour. 1/10 of a kilowatt hour might not sound like much, and honestly, it's not. That's why you build multiple systems, or you combine this earth battery with other small sources of generation. Fence, LED lights, night glowing, backyard. But here's what's important. 1/10 of a kilowatt hour is real power. That's enough to run a moderately bright LED light for 8 to 10 hours every single night, month after month, year after year, with zero fuel cost, with zero moving parts, with zero maintenance beyond checking on it occasionally. If you have just fence lights, and most Americans over 60 do, then a single earth battery system can literally power all of them every night for free. That's probably $30 to $50 a month in savings, right there. For a retiree, that's significant money. If you build 3 or 4 of these systems in different areas of your yard, which costs maybe $200 total and takes a long weekend, you're now generating enough power to run outdoor lights, a small LED grow light for a winter garden, maybe even a low-power heater in a shed or garage for extended seasons. Backyard, multiple systems setup, night lights. Now let's talk about what almost everyone gets wrong about this kind of project. The first misconception, you don't need to understand the physics to build it. And that's true, you don't. But you do need to understand what it can and cannot do. It cannot power your whole home. It cannot replace your utility bill entirely, at least not with this single approach. It can generate a small but meaningful amount of power for specific applications. Lights, ventilation fans, maybe a small radio or phone charger. That's it. The second misconception, it's free. It's not. You're buying materials, you're spending time. The payback period, the time it takes for the savings on your utility bill to equal the cost of your materials, is usually 2 to 6 months, depending on what you're powering and what your local electricity rates are. After that, it's genuinely free, but you need to do the work up front. Calculations, paper notes, doing math. The third misconception, once you build it, you never have to think about it again. Not quite. You should check on your systems every 3 to 6 months. Look for corrosion on the above-ground wires. Make sure your rechargeable batteries are actually holding a charge. If you notice the light dimming, it might mean your soil has dried out and you need to dampen it again. It's minimal work, 10 or 15 minutes a few times a year, but it's not zero work. The fourth misconception, and this one matters, you can power anything with this system. You cannot. The power output is too low and too inconsistent. You shouldn't be running power tools off this. You shouldn't be charging a laptop. You shouldn't be running air conditioning. That's not what this is for. This is for low power applications. Lighting, ventilation, maybe a small backup charger for essential devices. Understand those limitations, accept them, and you've got a workable system. Try to exceed them, and you'll be disappointed. Charging adapter outlet, small device. Now, here's what I think most people miss about why this matters, especially for someone on a fixed income. It's not really about the absolute amount of money you save, though that matters. It's about recovering a sense of control and self-reliance. For most of your life, maybe 70, 80 years, you've had to trust the utility company. You paid their bill. You used their product. You had no choice. The moment you start generating even a tiny fraction of your own electricity, Something shifts psychologically. You've proven that you don't have to be completely dependent. You've demonstrated that with some knowledge, some time, and some minimal resources, you can provide for yourself. That's not a small thing, especially in retirement. Man, backyard sunset proud, home system. Combine this earth battery approach with other small generation methods. A small solar panel here, a hand crank generator there, maybe a small propane heater to reduce winter heating costs, and suddenly you're not just saving money on your utility bill. You're building a knowledge base. You're learning how to think about energy differently. And that knowledge transfers. Once you understand how to generate power, store it, and use it efficiently, you can apply that to all kinds of problems. Backup power for a medical device, outdoor lighting without running new electrical lines, a cooling fan that runs all night on batteries you charge during the day. Most of those things would cost thousands of dollars if you hired someone to install them. But once you understand the principles, you can do them yourself for a few $100s. That's the real value. Let me walk you through one more practical example of how to expand this concept beyond just a single buried battery. Let's say you've built your first earth battery system. It's running your fence lights, you're happy. But now you're thinking, what about the back patio? What if I want lights out there too? Option 1, build another earth battery, bury it in that location, and run a separate set of lights. Option 2, use the same rechargeable battery, but connect it to multiple light circuits so the power goes in several directions. Option 3, build a second earth battery in a different location, set it up to charge a dedicated battery, and have that battery power the lights in a specific area. System diagram comparison illustrated 3 options. Most people choose option 1, and that's fine. But I'm going to suggest that if you're serious about this, option 3 is actually smarter. Here's why. If you have 2 separate earth battery systems, each charging its own dedicated battery, you've got built-in redundancy. If one fails, the other still works. You're not dependent on a single point of failure. Plus, if one location generates more power than the other because the soil conditions are better there, that battery charges faster, and you can actually generate more total power across your yard. It's a slightly more complex setup, but not by much, and it costs maybe $50 more. Backyard, multiple lights separate, night outdoor. This is the kind of thinking that separates people who dabble with DIY energy from people who actually build working systems. You have to think about redundancy, reliability, and scalability from the beginning. You're not just building a novelty setup to impress your friends, you're building infrastructure that works, infrastructure that lasts. Now, before we move to the next section, I want to mention that we've covered the basic principles here, but there's so much more depth to this topic. How do you weatherproof your components? What happens if you want to expand to a higher voltage for more complex applications? How do you troubleshoot if something isn't working? Weatherproof copper tubing, sealant protection, outdoor components. The weatherproofing question is absolutely critical, and it's where most backyard builders stumble. Copper and salt systems work beautifully in theory, but nature is harsh. Rain finds every gap, moisture creeps in, corrosion accelerates. Sealant application, waterproof sealing, copper protection. The solution is marine-grade silicone. Not standard caulk, marine-grade. This is what boat builders use. It stays flexible through temperature swings, resists UV degradation, and doesn't crack or peel. A single tube costs about $3, and one tube will seal dozens of connection points on a basic system. Your buried components are protected by soil, which is actually nature's insulation. But anything above ground, your junction boxes, your battery terminals, your electrical connections, those need real weather defense. PVC conduit sleeves around exposed wiring, silicone at every seam, and periodic inspection twice a year, spring and fall. That's it. Inspection maintenance, older man checking, electrical box. If you notice white powder forming on your copper connections, that's oxidation. It doesn't mean failure, it means it's working. You clean it gently with a soft brush and a tiny bit of vinegar, then reapply the protective sealant. This takes 5 minutes and costs nothing. Cleaning copper, maintenance tools, vinegar brush. Now, let's talk about voltage expansion. Most people starting out build systems in the 5 to 12 volt range. That's safe, manageable, and plenty for fence lights, small LED strips, and basic charging applications. But what if you want to power something larger? What if you want to run a small refrigerator during a blackout, or charge multiple devices at once? Electrical system comparison, DIY power setup, voltage expansion. The jump from low voltage to medium voltage, say 24 or 48 volts, is a completely achievable weekend project. It's not harder in principle. It's bigger in scale. Your copper pipes might be thicker, your salt solution might be in larger containers, your wire gauge changes, your battery storage capacity increases. The fundamental chemistry stays the same. You're still creating an electrochemical reaction. You're still storing that energy. But now you're doing it in a way that produces enough power to run larger devices. Copper conductor crimping, electrical connections, thick wire. The rule is simple: thicker pipes, larger containers, heavier gauge wiring, and professional connectors instead of twisted connections. A crimping tool costs $15 to $20. Crimped connections are waterproof, corrosion resistant, and stable for years. Twisted connections fail. Don't be the person who builds something that fails. Twisted versus crimped connections, electrical integrity, wire connection. Now, troubleshooting. This is where patience meets common sense. If your system isn't producing the voltage or current you expected, you run through a simple checklist. First, are all your connections clean and tight? Corrosion or loose connections kill performance instantly. Second, is your salt solution at the right concentration? If it's been sitting for months, water evaporates and the concentration changes. You might need to add a little distilled water or a touch more salt. Third, are your copper pipes actually in good contact with the solution? If there's air trapped between the pipe and the liquid, that section isn't working. Multimeter testing, voltage check, troubleshooting. A simple digital multimeter, $10 to $15 at any hardware store, becomes your diagnostic tool. You measure voltage between different points in your system. If the voltage is lower than expected at point A, but normal at point B, the problem is between A and B. Could be a connection, could be corrosion, could be a break in the wire. You've narrowed it down. This is how real systems are diagnosed. Digital multimeter display, voltage reading, testing tool. Most problems are simple: a loose connection, a dirty contact, or a concentration issue in your solution. These are all 5-minute fixes. Once in a while, you'll have a true component failure, a crack in a pipe, a corroded section that's beyond repair. That happens. When it does, you replace that section and move on. The beauty of modular systems is that you're not replacing the whole thing. You're swapping one component. Modular component replacement, copper pipe swap, system repair. Think about this way. You wouldn't rebuild your entire car if you had a bad alternator. You'd swap the alternator. Same principle here. Build your system in sections that can be independently maintained or replaced. That's professional thinking. Complete backyard system, multiple energy sources, integrated setup. A common question people ask is, how long does one of these systems actually last? The answer depends on your maintenance, but we're talking years, not months. The salt solution will eventually become depleted. That's usually 2 to 3 years depending on current draw and weather exposure. When that happens, you drain the old solution, rinse the containers, and mix fresh solution. Cost, maybe $8. Time, 30 minutes. Copper piping itself lasts decades if it's properly protected from corrosion. Your wire, your connections, your junction boxes, if they're quality components and properly sealed, will outlast the salt solution by a significant margin. The battery storage component, if you're using rechargeable batteries or a capacitor bank, might need replacement every 5 to 7 years depending on use. But that's not unique to this type of system. That's just batteries. Salt solution inspection, battery maintenance, system check. Here's what separates a weekend project from a real backup system. A real system gets checked regularly and maintained proactively. You're not waiting for a blackout to find out it doesn't work. You're checking it monthly when there's no emergency. So when there is an emergency, you know exactly what you have. Maintenance calendar, system log, record keeping. Keep a simple log, date, voltage reading, observations, any work done. This takes 3 minutes a month. After a year, you have 12 data points. You can see trends. You'll know if your system is drifting in performance or if it's stable. That knowledge is gold on a fixed income. You're not guessing, you know. Energy guide manual, instruction reference, DIY manual. If you want the complete troubleshooting flowchart, the exact maintenance schedule, the specific salt concentrations for different voltage targets, and video walkthroughs of every step of this process, that comprehensive guide is available in the description and in the pinned comment. It goes deep into the systems we've only touched on here. Now, let's talk about something most backyard builders miss entirely: safety. Electrical ground, safety grounding, earth stake. A properly grounded system is not optional. Grounding protects you and protects your equipment. If there's ever a fault or a surge, the current finds a safe path to earth instead of finding its way through you. A simple ground stake, copper or galvanized steel, driven into the ground 30 inches deep, connected to your system with proper gauge wire. That's your insurance policy. The rule is, if you're building anything that generates or stores electricity, it needs to be grounded. Not eventually, not after you test it, from the beginning. Grounding is free protection. Electrical safety explanation, grounding demonstration, expert advice. Beyond grounding, you need to think about overcurrent protection. If your system starts producing more current than your wiring can safely handle, something needs to shut it down before the wire overheats. That's where a simple fuse or a circuit breaker comes in. For low voltage systems, 5 to 20 volts, you're looking at automotive fuses, which are cheap and effective. For higher voltages, a standard circuit breaker rated for your system's maximum expected current. The calculation is simple. If your system produces a maximum of 5 amps, you use a 5 amp or 6 amp breaker. This takes the guesswork out of it. Automotive fuse selection, circuit protection, overcurrent device. Cost: a fuse holder and a set of fuses, $5. A small circuit breaker rated for your system, $8 to $12. This is not a place to save money. This is where you spend a few dollars to avoid a fire or serious equipment damage. Electrical hazard fire risk, overheated wire, danger warning. I've seen people skip this step because they think their system will never produce that much current. That's the exact moment something goes wrong. A system gets wet, a connection shorts. Suddenly you're at twice the expected current. And if there's no protection in place, you have a problem. Real systems have protection. Full stop. Finished solar setup, complete power system, working installation. Let me ask you something. How much would you pay to never get a surprise utility bill again? How much is peace of mind worth when you know you can run essential systems during a blackout without relying on the power company? Most people think about cost only in terms of the initial build. That solar panel cost $400. That battery cost $200. But they never think about the math the other way. High utility bill shock, frustrated homeowner, determined expression. If you're paying $150 a month to the utility company, that's $1,800 a year. That's about $22,000 over a 12-year retirement. And utility rates aren't stable. They climb 3 to 5% every year. So in 20 years, that's potentially $50,000 leaving your fixed income household. A complete DIY setup that covers 50% of your baseline power needs. Fence lights, patio lights, phone charging, small appliances, costs under $500 to build. Properly maintained, that system works for a decade with almost no additional investment. After the first year, you've started recovering that investment through lower power bills. After 5 years, you've saved more than $5,000. After 10 years, you've saved $20,000. Cost comparison chart, savings over time, rising bills. Now, that math doesn't even account for inflation on fixed income households. When your retirement income is fixed and utility costs rise every year, that's a real squeeze. But when you own your power, when you generate it yourself, you're protected from those increases. That's not just financial, that's emotional, that's security. This is why building redundancy matters. This is why you build multiple systems instead of one big system. If you have 3 independent light systems and one fails, you still have 2. You haven't lost everything. You're not helpless. That reliability, that independence, that's the goal. A multiple independent systems, distributed power, backyard redundancy. A neighbor gets a 3-day blackout in a storm. They're sitting in the dark, you're reading by your backup lights, charging your phone with your system, running a small fan in the summer heat. You're not uncomfortable. They are. That difference is freedom. Let me tell you what happens next. When you build your first system and it works. Hands solar panel inspection, homeowner satisfaction, backyard power. You prove something to yourself that matters more than any utility bill savings. You prove that you can still build things, that you can still solve problems, that you're not dependent on waiting for a company to fix things for you. That independence isn't something you lose when you turn 60 or 70. It's something you earn every single time you set up a system that works. Backyard at night, fence lights glowing, DIY workbench. The first time your backup lights come on during a storm while your neighbors are scrambling for flashlights, something shifts inside you. You're not anxious, you're not worried. You're calm, because you know what you've built actually works. Your system is real, your independence is real. That calmness is priceless when the grid goes down. Calm interior, backup lighting, peaceful home. And here's what most people never tell you about building your own power systems. It's not just about the money you save. It's about the competence you build. Once you've successfully installed one system, whether it's an earth battery, a hand crank backup, or a small solar setup, you understand what's possible. You understand that you're capable of more than you thought. That changes how you see your retirement. That changes everything. Older person working, DIY projects, hands-on building. I've heard from viewers who started with one system 5 years ago, and now they're running backup power for their entire home, helping neighbors understand their options and sleeping better at night because they know they're not vulnerable to a sudden power bill spike. They started exactly where you are now. They started with one simple idea: I'm going to take control of this. And they did. The path is simple. Start small, build one system, make it work, test it in real conditions, then add the next one. Each system is independent. Each one teaches you something. Each one brings you closer to the security and independence you actually want. Homeowner pride, backyard systems, golden hour satisfaction. You don't need permission from an electrician. You don't need to understand advanced physics. You need a clear plan, the right materials, and an afternoon to build it. You need to believe that you're still capable of solving your own problems. And you are. If you want to go deeper into how to design your first system, what materials actually work without breaking the budget, and how to avoid the mistakes that most people make when they build their first backup power setup, the complete guide is available in the description and pinned in the comments. It walks you through every step, the cost breakdown, the material sources, the installation process, and how to test your system so you know it's reliable before you depend on it. Smartphone guide ebook, description link, older hands. That guide is what bridges the gap between watching this video and actually building something that works. Instructional content tablet, reading guide, detailed steps. The second thing you should do is spend some time thinking about what failure looks like for you. Not in a negative way, in a practical way. What happens if your primary backup system fails? What's your backup to your backup? That's not paranoia. That's planning. That's wisdom. That's the kind of thinking that keeps you safe and independent when things go wrong. Most people spend more time planning their grocery shopping than they spend planning for a 2-week blackout. You're going to be different. You're going to be prepared. Handwritten planning notebook, backup strategy, notes. Write down what systems you have. Write down what each one can do. Write down what happens if one fails. Write down where your critical needs are: refrigeration, lighting, medical devices, communication. Then build systems to cover those needs. That's not complicated. That's practical. That's exactly the kind of thinking you've been using successfully your entire life. The difference now is you're applying it to your energy independence instead of leaving it to chance. Confident homeowner planning, backyard review, organized preparation. You've already demonstrated the most important skill this requires: the willingness to learn something new. The fact that you're watching this video means you believe you can improve your situation. That belief is everything. The rest is just details and materials. Start this weekend, pick one system: the Earth battery, the hand crank backup, or the solar setup, whichever one fits your budget and your space. Spend the afternoon building it, test it for the next week, see what works, see what you learn, then come back and add the next system. This is how real independence gets built. One weekend at a time, one system at a time, one victory at a time. Sunrise Backyard Pride, completed systems accomplishment. Your utility company is counting on you staying dependent. They're counting on you believing that managing your own power is too complicated or too expensive. They're wrong. You've already proven you're capable of managing a household, raising a family, building a career, and making smart financial decisions on a fixed income. You're absolutely capable of this. The only thing stopping you is the first step. If you're serious about building real backup power and going deeper into the systems and strategies that work, the complete guide is waiting for you in the description and in the pinned comment below. It's got everything: real material lists, real cost breakdowns, real testing procedures. This is the guide that takes you from interested to actually building. Backyard power system dusk, independent lights functioning, homeowner satisfaction. Thank you for watching this video. I hope it's given you confidence that you're absolutely capable of taking control of your energy costs and building the independence that makes retirement actually feel like freedom. If this resonated with you, please subscribe to the channel, hit that like button, and turn on the notification bell so you never miss a new upload. We're releasing new practical power systems and budget builds every week, and I want to make sure you see them. You've earned the peace of mind that comes with true energy independence, and I'm here to help you build it. Take care. Fade to black. Peaceful ending.